Hi, my name is Andres. I'm an engineer with DesignPoint Solutions, and today we're going to be talking about designing with sheet metal. As engineers, we have to constantly be thinking not just about functionality or even aesthetics, but we have to make sure that our parts can be manufactured. So we have to closely work with manufacturing in order to ensure that that happens. Otherwise, well, we'll hear from them. The less back and forth we have, the more efficient we're going to be. So ideally, we create parts that are functional and manufacturable the first time. Doing these can be quite a task, but luckily we have the right tools that make these easier. Let's take a look at how SOLIDWORKS can help us efficiently model for manufacturing. We're going to be focusing on how we can add industry standard features while making sure that the part is still manufacturable. Then we're going to discuss how we can clearly and efficiently communicate all this great information to our manufacturing team.
So now inside of SOLIDWORKS, we will start creating the sketch geometry that will define the shape of our sheet metal part. We're going to type in a couple of dimensions and we'll add certain relations that will fix the sketch in place. This is a very simple process. The next thing that I'll do is I'll set up some of the Sheetmetal parameters that will drive this model. The first value I'm going to type here determines the depth of my base flange. Next, I'm going to drive these with a gauge table to make sure that the thickness and the bend radius are some of the standards that my company can manufacture. I'll select gauge 18 and a 2mm radius. So just like that, we're making very fast progress while making sure that we're maintaining company standards. The next thing that I'll do is I will add more edge flanges. For this next one, I'm going to put it all over the tangency of this front edge, so no need to select multiple edges. Next, I'm going to type in the value for how far in or out I want my flange to go and flip the orientation. Lastly, I'm going to determine if my bend will happen outside or inside of my sheet metal part. For the next edge flange, however, we will have a different challenge. In this case, we want to modify the profile of it, which is a simple task in SOLIDWORKS. We're going to be able to just drag our geometry, add dimensions and relations, just like we did with the first sketch that was defining the geometry of our sheet metal part. Here I'm going to add a tangent arc, and at my fingertips I have more control over some of the tools that will help me fully define this particular sketch. So notice how simple and easy it is. I don't have to navigate the SOLIDWORKS user interface in order to get to the tools that I need to use. Finally, I'll drop in the last dimension here to tie that in place. I'm going to finish this command, and just like that, this new edge flange is created. If we zoom into it, SOLIDWORKS made some decisions for me and gave me the relief cuts that I need in order for that to be able to be manufactured. It so happens that in this particular case, I need to add a couple more instances of that. So instead of recreating that geometry, I'm just going to rely on some of my patterning tools, and by determining a direction, how many instances I want and the distance between them, I can achieve the result that I want in no time. Next, I will create these same features on the opposite side so that we have a fully symmetrical part. In a couple of clicks, once again, we achieve the result that we want. The next flange we will create will bend 3 different times. And in order to stay as efficient as we can be, we're going to create them in one single feature. Just like before, we're going to add some dimensions and relations in order to fully define our geometry. Now, allow me to show you which are the edges that I want to make part of this particular feature. I want to propagate this flange along the tangency of this highlighted edge. So with a click of a button, I can select all of them. Because we're working in the sheet metal environment, SOLIDWORKS knows that I will need a relief in the corners in order for my bends to be able to be manufactured. Here I can tweak the settings, hit OK, and my flange is created.
As you can see, we're well on our way to create a fully functional and manufacturable part. We were able to quickly select a standard bend radius and material thickness. Reliefs were automatically added and multiple bends were created in a single feature. Now let's move on and add some final details that will allow us to fix these in place, and also some features that will facilitate the airflow through our enclosure.
Hems are frequently used in the sheet metal industry in order to prevent exposed sharp corners for safety and aesthetic reasons, among many others. In this case, the hem feature within SOLIDWORKS will offer us a couple of different options that are actually standards in the industry. Now, if we take a closer look at our hems, we can see that SOLIDWORKS properly formed the material so that in the end we can have a flat pattern. If we wanted to create a cut on the flat pattern of our sheet metal part, we better make sure that it happens normal to the material thickness. Otherwise, our CNC, water jet, or laser cutter won't be able to handle it. Luckily, in SOLIDWORKS, we have an option to automatically create normal cuts, so that we don't have to worry about not being able to manufacture them. If we closely inspect our part, we notice that the cut indeed is created normal to the thickness of the material. A testimony of that is these two faces, which are not parallel. Something else that is frequently used in the sheet metal industry is forming tools. In SOLIDWORKS, through our design library, we have access to a variety of standard forming tools that can be customized. Using them is very simple. We simply drag and drop them onto our geometry, and then we specify certain settings to satisfy the requirements of our design. As always, the last step will be to fully define the location of our feature by applying certain dimensions and relations. It looks like our sheet metal enclosure will need a couple more vents on top in order to ensure proper ventilation. So we can easily achieve these by creating a linear pattern specifying how many instances we want and the spacing between them. To ensure that a part remains symmetrical, we're going to mirror these features over to the other side of our enclosure.
So just in a couple of minutes, we were able to utilize the tools inside of SOLIDWORKS, including our handy design library, to create formed features as well as manufacturable cuts, and in the end we created a standard hem. Now it's time to pass this great information along to our manufacturing team, and this is a critical step. Even if we have designed a perfectly manufacturable part, it isn't worth anything unless we can clearly communicate these to the manufacturing team. Let's take a look at how SOLIDWORKS makes this process a very simple one.
Now let's take a look at our flat pattern. After all, this is the most important piece of information in a sheet metal environment. Exporting these as a DXF or a DWG, it's not only a very simple process, but also when we do so, we get exposed to a couple of options that will allow us to export the geometry, library features, forming tools, among other things. Once the DXF is produced, we will have the option to clean up the geometry so that we don't send the wrong information to the laser cutter, water jet, or CNC. The next step in the process will be to properly document, using a 2D drawing, the design intent of our sheet metal part. There's no need to recreate the views. We can simply drag and drop onto a sheet the views that we want to create. We will notice that the bent lines and the relevant information is captured inside of our view. But if we wanted to clean up a little bit our page, we can simply insert a bend table, and now our view will be a lot cleaner. Now let's document our punches. Let's use a punch table. For these, we will have to select the location that we will be measuring from, and then the rest is done by SOLIDWORKS. A table is automatically generated with the relevant information, such as the punch IDs and the location of the features. Lastly, we'll do the same thing for the holes. Using a hole table, we will select the location to measure from, and then a table will be generated with the relevant information regarding the size and the location of our holes.
Using the tools available in SOLIDWORKS, we were able to quickly generate a DXF and send it to our laser jet. Also, we documented our holes, punches, and bends accurately and with minimal effort. Overall, SOLIDWORKS saves us a ton of time and it makes sheet metal design a breeze from start to finish, ensuring that our designs become a reality. Thank you for following along. If you enjoyed this video, be sure to check out the rest of our content on Facebook, YouTube, and LinkedIn. See you the next time.